Okay, hello everybody. Welcome to this panel session for the MIPI DevCon 2021. Today we're going to be taking a look at MIPI I3C. We've got a assembled panel of I3C experts at our disposal to take us through this subject matter today. We have Tim McKee from Intel. Tim is systems architect at Intel Corporation. He works to create and enable standards for industry advancement. Tim is our I3C Working Group chair. In a moment, Tim will give a little introductory presentation to I3C to bring us up to speed in terms of latest developments. We also have Matthew Schnorr. He's a debug architect at Intel. As well as being a member of the I3C Working Group and MIPI Debug Working Group, Matt presently leads the I3C HCI subgroup. And Matt's been a lot of work recently in bringing I3C support to the MIPI debug interface. We also have Yul Teferi from ST Microelectronics. Is currently a senior hardware design engineer in the MEMS sensor division at ST. Yul is also currently vice chair of the MIPI I3C Basic ad hoc working group. And last but not least, we have Radu Pitigoy-Aron, principal engineer at Qualcomm Technologies. Radu is amongst one of the initial developers of the I3C interface and brings a whole wealth of experience on the I3C interface with him. He pays particular interest in system performance whilst also drastically reducing energy expenditure. So Radu's going to talk a little bit later about some of the features, key features of I3C and how you can leverage those for really efficient system designs. Okay, so that's our panelist for today's session. Let me now hand over to Tim McKee, chair of the MIPI I3C Working Group, to just bring us up to speed on the latest developments within the I3C and I3C Basic specifications. Over to you, Tim.
Great, thank you, Ian, and welcome to everybody. We're grateful to have you here. I just wanted to jump in and be able to kind of give a high-level view of what's gone on and the changes that we've been working on in the world of I3C. So for those who have been paying attention to the MIPI website, you'll see we've got some new specifications for 2021. Both the I3C and I3C Basic are now revved up to a version 1.1.1. And with these new versions comes a lot of new stuff. So for I3C, there's a lot of clarifications. We did a terminology change to get into more inclusive language, as well as including a target reset, which was a white paper back from the 1.1 and 1.0 version. For Basic, we started adding in a lot of our I3C features, clarifications, but one of the major things that we did is we just synchronized the specs together so that I3C Basic and I3C are now aligned together on this version 1.1 specification. On top of that, we have our I3C host controller interface version 1.1, which I'm excited for Matt to talk about a lot more later. But there's been a ton of work that's gone into these specs, and we're excited to really share them with you. On top of that, we've worked to make sure that I3C is getting its fingers out into the industry, and we've partnered with some incredible organizations, including JDEC, DMTF, and we're developing other relationships as well in order to just expand the use of I3C and increase increase the number of places that I3C is being used. And then finally, we want others to get involved. You know, I'm a firm believer that two heads are better than one. We've already got incredible experts and great engineers working with us on this product, but we always want more, and we want feedback as well. And so we work regularly. We meet within the MIPI work group Wednesdays, 8 a.m. And you know, if you have questions, comments, anything, we want to hear from the implementers. We want to hear from the people that are using this technology. And so please contact us through either of the MIPI emails listed here below. And then also keep an eye out for our supporting documents. They're starting to be released now, but FAQs, app notes, errata, we're committed to continually developing and supporting this technology, and we're excited to do so. So please do check out the links. Come pay us a visit if you have any intention to come help us develop this technology further. We would absolutely love to hear from you. So that's it from me, Ian. I'd love to just hand it back to you.
Thank you, Tim. So thanks for that very quick introduction. I'd like to ask the panelists to now switch on their cameras and microphones, and we'll run through some questions in our panel session. So Tim, obviously in your presentation there, you've just stated we have new releases of both I3C and I3C Basic. Obviously the I3C update is quite minor, but the I3C Basic specification contains now some really key new features which align it, as you say, more closely with the full I3C specification. So I wanted to ask you if you could perhaps highlight those key new features, perhaps explain to the audience, what the key benefits are of those new features and how, the audience here might use them going forward.
Yeah, absolutely. As you said, the I3C version 1.1.1, it was more of a cosmetic fix. We wanted to clean things up. But when it came to Basic, we did add some very important features. For instance, and most of these, if you've used the I3C full version, you'll be familiar with. But things like timing control. We wanted to allow the ability for targets and devices on the bus to be able to synchronize events, be able to increase timing accuracy through timestamping, and things of those nature. We added in HDR modes, which was a big piece of work. These HDR modes allow us different clock and data transmission models so that we can now increase the throughput. So now we're, instead of, the throughputs we were seeing, we're now able to reach on single lane up to 12.5 megahertz in I3C Basic. So that's a huge step up there. Another feature added that is great is this group addressing, right? So this is to increase efficiency a lot. Now you can have multiple targets on a bus that share one group address. So now instead of having to address each target individually, we can send one command, it addresses all that group of targets, much better for efficiency that way. And these are all perfectly and well configurable through CCCs. Right, which brings me to that we've expanded the CCCs that are available, which are the common command codes that are available in I3C Basic, not only to support some of these new modes that I'm talking about, but others as well too. And so there's a ton of expanded capabilities, all sorts of new stuff. A little much to list right now. I'd love, we've got some other great panelists on here. Any other key features that anyone else is excited about?
For me, it's really about how I3C Basic is positioned to be usable by other standards and emerging technologies. We see things like target reset pattern and various ways to reset an I3C target. I mean, that's a key thing for resetting a thing in band. Tim mentioned group addressing. We see set buscon, the CCC that allows people to program devices on the bus about various contexts and basically set the context of the bus and how things are to be used and what sort of content protocols they're to be responding to. We see clarifications. We see improvements in how secondary controller devices, hot join, dynamic address assignment, all these things really add up to a new version of I3C Basic in a way that really sums up the best of what everybody in the I3C ecosystem and community has put time into and developed and can bring out for various integration standard organizations and integrations. And that to me, I think is just, it's also a fresh coat of paint, but it really is also kind of a deep understanding of what we can do better based on how implementers have looked at things and how we've positioned things.
Thank you, Tim. Matt, other panelists, please.
Yeah, if I may. So another thing that it's interesting and important for our philosophy in developing the I3C was the backward compatibility. So we don't want to lose contact with what is already built. So all of those new features, it took a lot of work, and many smart people are actually contributing to that, such as to do not destroy what we have, we just add on that fundament that we have. So all the new features are actually useful and usable within the ecosystem. You don't have to come up with something, breaking something and make something totally new.
Thank you, Radi. So we've got some really powerful updates. We've made it as easy as possible for existing implementers to transition to this new specification, use these new features to the benefit of their new systems designs. That perhaps brings us to another question. You mentioned, I think, on one of your slides, Tim, that obviously many other industry groups are looking to adopt I3C into their into their particular standards, into their solutions. Perhaps you could just tell us a little bit more about which groups you're working with, what they're doing with I3C, and why perhaps they've chosen to select I3C as an interface of choice.
Yeah, absolutely. We're very excited about the liaison activities that we've been able to conduct. They've been a lot of work, a long time in the making, but there are two outstanding organizations that we've already delivered standards on, and that one would be the JDEC organization, where we worked with them to create the SPD standards, which are playing a huge part in memory modules, as well as supporting sensors within memory. And so JDEC is a huge organization, and so one of the joys of this is anytime I3C we jump in with another one of these organizations, our reach, our influence expands so much. And it just allows us to get better as well too. It's one of the greatest things is we're sitting down, we're working with some of these experts, they're sharing their knowledge, we're sharing ours, and it helps us to improve our technology as well. So the JDEC SPD, it's being used DDR memory all over the place, so that was a big move for us. On top of that, more recently we have a approved spec from the DMTF organization. For those that have been around in the I2C world for a while, may be familiar with an I2C binding spec that came out of them. Well, we took that up to the next level with I3C binding over MCTP. And so this was a big bus management win for us, a bus management interface. It allows us to use the greatness of I3C with the security of MCTP, and allows us to really take advantage of some of the other things that maybe I3C didn't quite contain that some of these other technologies do. And so you get to put the best of two worlds together. On top of that, we're working on other liaison and other projects, things like PCI Express, working on a sideband signal there, and working with the organization there. AFI, automotive side, IEEE 1722. These are all projects in the work with the I3C Working Group, as well as other organizations. Like I said, we want this technology out there. We see great value from I3C, and other organizations are seeing it as well, as why we're continuing to develop these partnerships.
Thank you, Tim. Other panelists, your views on the liaison activities?
I just would like to add some point that Radu has already mentioned. The fact that I3C is capable of supporting backward compatibility and able to support I2C means that adopting I3C into these standards that are standards and organizations that are already using I2C can easily shift to I3C while maintaining backward compatibility also for their platforms that they are designing. This means that I3C is not only supporting to move to the future, but it's also able to keep and maintaining the backward compatibility of industries and organizations that are already using I2C as a feature and as a protocol for communication as well. So this is also one of the big advantages of I3C.
Yeah, thanks, Yul. Yeah, absolutely. Yeah. Would others like to say any words about the liaison activities? If not, let's move forward. So I think one of your slides, Tim, you mentioned there's a key companion specification to the I3C, and that's the I3C host controller interface, which has also recently been updated. And as I mentioned at the top of the session here, we've got the lead of the I3C HCI subgroup here in the shape of Matt. Matt, just wondered if you could perhaps tell us a little bit more about HCI, why the specification was created, what the benefits are of the HCI specification.
So the big benefit of HCI as a host controller interface is to standardize how hosts can send in transfer commands, interact with the I3C bus, and get responses back out in a standard way, and to be able to have data structures or descriptors, if you like, that describe these things, and that you can have common software above this stuff that really takes advantage of a standardized host controller like that. So, I mean, in theory, a common host controller device can be integrated into silicon at many different levels, from small things like microcontrollers to applications processors, or even peripherals in a PC class device. And there are some that have these things. And the fact that there's a standard interface means that you can have common software, you can have even hardware that integrates directly with these things. And people don't have to have differing interfaces for these things in all cases. And I think this actually enables the I3C ecosystem as a whole, because it provides a good foundation. It provides a great starting point for application developers. They don't need to think about, where do I start from scratch? Do I need to create a new register-based interface? Do I need to create a new memory transfer interface for this stuff? Not necessarily. You have a standard. There is a place you can go to start from this stuff. Recently, HCI 1.1 has been released. We've got some new capabilities in here. We actually think we're going to help grow I3C in a big way. I mentioned being a component of our integrations, but the other thing that makes sense for this is, where's the software? We now have a common HCI driver that integrates with the Linux I3C subsystem. Now, MIPI helped to develop that, and it's available now. We expect that's probably going to get picked up and ported into other real-time operating systems fairly shortly. This is a great enabling step to enable I3C target device access in a common way for application processors, MCUs, and even PC class devices. So where we're going from here, we're looking at what the industry is going to need. We're looking at things that our implementers need. We're looking at ways other MIPI work groups need. For example, debug for I3C, future camera specifications for camera control. We're going to be looking at where to take this in the future for what makes I3C more usable, what standard interface features are needed, and how we bring these capabilities to a standard ecosystem in a way that doesn't break backwards compatibility and provides access to new things, and also provides extendability for implementers. And I think that's why HCI is poised to become a very important piece of enabling the ecosystem here.
Great, thanks for that overview, Matt. Others would like just to add your thoughts on top of Matt's summary there? If not, Matt, I'll just turn back to you. I mean, obviously, you mentioned that obviously the work goes on. We have 1.1, but we have future releases. Would you like just to say anything about kind of what's happening next inside the inside the subgroup?
Sure. So the subgroup's looking at new features that are going to enable reliability. We've got a bus recovery feature we want to bring in and make supported. That's going to be necessary for debug integrations. We've got some things that are going to enable some transfer modes for data transfer termination for HDR modes. That's something that we would like to support. We've a couple of features for camera control for an upcoming MIPI specification for smart camera devices that we want to be able to support as well. We've got a couple of features in plan for the near term and a couple others for the long term, perhaps HDR BT mode. We're going to try to find a way to integrate that and pull that in as well. And we feel that we can make a standard interface that's going to be able to give most of the people most of what they need and meet that need. And that, I think, is why HCI can be very successful here. We realize that not everybody is going to be able to use HCI as their thing. There are other interfaces that we're fine with that, but we want to make HCI great at what it's going to be able to do.
Okay, thank you, Matt. Sounds like you've got a absolute ton of work lined up, and obviously the HCI is going to go from strength to strength.
We're trying. Okay. We're open to contributions and helpers as well too. That would be a great.
I just want to say something here. I don't want to kind of jump over Matt. Matt is great what you are saying, and again, just because you're saying how we support the integration of I3C in other MIPI specifications, another organization. I just want to say again that we are not only developing the I3C, we are a very active and enthusiastic supporter of integrating the I3C within our colleagues from MIPI and in other organizations, as UL was saying. So examples like in the camera, the new AOSC feature, which is there as well. But the debug you just said, then on the display, all of those. What I'm trying to say here is that ask us. We are here to help, and we are big fans of I3C. And whatever we can do, we will do. We go over and above what is actually really expected. So I look forward to get your question and try to help, and my colleagues here as well.
Yeah, thanks, Radu. I think absolutely key point that we want to do whatever we can to improve our specifications, evolve them, make them better, make them greater value to a developer community as much as we possibly can. And obviously, contribution is key to that happening. Okay, so if it's okay to just sort of move forward, I'm keen to sort of talk a little bit about I3C and some of the key features the specifications support. I'm going to quote from the MIPI website. It describes I3C as an interface that gives developers unprecedented opportunities to craft innovative designs for any mobile product, from smartphones to wearables to systems in automobiles. So it's a grand statement. I'd like to turn to Radu to perhaps tell us, a little bit more about I3C, some of the advanced features it supports, and basically kind of back up why we're making these grandiose claims about the I3C interface, because I think we can. I think there's plenty of capabilities there. I just wonder if you could perhaps give us a flavor of some of the capabilities and how they might be used.
Well, thank you very much. I think we shouldn't go that far and saying that it's the best, it's extraordinary or anything, but for the very beginning, the intention of the developers of the I3C was to be actually a worldwide wired interface, being an extraordinarily good alternative to I2C, to SPI, to UARTs, anything which is actually a wired interface with data rates under 100 megabits per second. And that, the immediate approach would be actually increase the clock. Well, we're not going that way. We are going to use the available hardware, the available I/O systems and everything, and do this. We increase the data throughput, increase it via an intelligent protocols. So it's just the protocol that changes. It's not the drivers, it's not the lines, it's anything. And then we wanted to have the same base for all the I3C modes. When we say I3C modes, we mean the various data transfer protocols. They are actually I3C modes. And at the same time, again, like we just saying, we look at flexible procedures. So you have to have your buttons, your handlers, so that you can actually adjust the application as suits better or best your direct application. Save money, at the same time saving time, saving energy, and everything. So there are several I3C features that I'm a fan of, and I won't be able to speak that much of anyone, but it's just like to mention, to open the thoughts of our auditors and to excite their attention to possibilities they might actually see straight in their own application. I don't want to mention any specific application. I just want to say here and there what those I3C features are actually able to do. So I will start with the HDR ternary modes. Now, HDR means high data rate modes. Ternary is actually an innovative mode of I3C, where the traditional clock line is actually not used as a clock. It is used as data transfer. So if you look at any other wire interface, you have this clock running continuously and getting energy. Well, ternary modes are actually based on phase differential decoding, coding, and decoding. And so the expenditure of the S clock line, it's actually gone. Then both wires transfer data, and what it is actually something that not many implementers have actually using is that the signals in this application, they start from the same point. So like that, you don't have the forward and backward time closure problem that you normally would have. And so the length of the lines extends, and you can eventually even increase the speed if you want. But we are actually focused initially for this 12.5 megahertz clock line that you have. And together with this fact, the fact that actually you have an emitter and that the receiver stays there and listens, means that for the very viewpoint, that receiver, it's passive and it cannot interrupt the coming, because the coming is actually active driven, and you don't want to fight against the emitter. Because of that, we were actually devising a flow control arrangement, which allows the receiver to intervene whenever it cannot get the data or is busy doing something else, and many other arrangements. And this is totally controllable, it is configurable, and more so, it actually gives the certification that both partners understand that the transfer, and so everything is actually safe. Now, so that will be in short the first thing. I don't think it was the short. Then we have the timing control. The timing control is got two main branches. One is for the synchronous events, and so that will be perfect. I mean, perfect, very useful to fusing events for AR, VR, MR, XR. Those are the major beneficiaries. And this system, it was intended to use as little as possible from the data throughput. It is very short, the information, and it is based on the reciprocal trust between the partners, and it allows the synchronization of, say, the sensors in one or in multiple clusters to pick up the samples at the same time, and then the read of those data could be actually delayed in time, because the reader, the host, or the controller in this sense, is to actually have everything there. And then this asynchronous event, which the MIPI arrangement, the I3C arrangement, does not need to know the frequency of the clock of the partners. So the system allows to transfer the information such as that everything moves on the timeline of the host. Still on this large array of applications, very often there is a bunch of data, a large bunch of data that has to go from one target to another target. Or there is a situation in which a monitoring target that looks for some very specific event has to transfer with an extraordinary speed to another eventually affected device. So normally what it is done in other implementations, the host will actually pick up that information from one device, it will read it, store it, and then excite the target device, the next target device, and transfer to that device the data. Well, that will imply, first of all, the latency, and second, the host has to have the capacity of storing temporarily that data. Well, the device-to-device tunneling feature of I3C goes over that. So it is an arrangement in which those possible users, in targets speaking, could actually be informed so that they can transfer, sorry, they can transfer the data from one to another without going through the host. And that one saves time and saves money and makes the application way faster.
Yeah. Okay, Radi. Thank you. I have to sort of interject there. Obviously, we could go on for quite a while. I think with going through the capabilities of the I3C. Right. I know you've highlighted a few key features there. I'm sure that there are plenty more. Obviously, I think what's clear to we can gather from your responses that there are a myriad of features that developers can leverage inside the specification. Obviously, we urge people to take a look in more depth. It's great that in the basic Vita 1.1.1, we've got even more capabilities brought from the sort of core specification and exposed to the developer community. Other panelists, would you like sort of highlight any sort of key features in the specifications that you kind of think, this is, perhaps a feature that you kind of really feel is worthy of the spotlight for our panel session today?
I think one of the other key features we need to bring up is, the ability of devices to power down and power up and kind of announce that they're back on the bus with a procedure we call the hot join, and that kind of gives a lot of flexibility to system designers when they want to, have a device that comes back up and says, "I'm back. I need to have an address assigned to me," and notify the host that things are back online now. So it allows for very fine-grained control over which devices, have power management states. You'll see a lot of those things in I3C where they talk about, power management, expectations of the controller, and how devices respond to that. And I think there's a lot of interesting cases where people could build in, things with power management, hot join, reset. And because I3C is a multi-drop bus, it really opens up a lot of potential for devices to have varying power states. I think we expect to see a lot of interesting things happen with that.
Okay, thank you.
Again, I will mention the multi-lane arrangement as well.
Oh yeah,
The flexibility. So you can have on the same bus devices they work on 2 wires, 3 wires, 5 wires with no problem to one another. They use the same cadence on the transfer.
Right.
Okay. Yep. Okay. Thanks, Radi. Well, I think we'll just stop. We'll draw the line there in terms of features, because we could go on for some time here. But there's one more important subject I'd like to cover today, and that's the subject of interoperability. Obviously, it's absolutely key with any interface specification that you have interoperability between different devices. Obviously, MIPI has done a lot of work on developing a conformance test suite to help implementers to help drive common implementations, interoperability between devices. I want to turn to Yul here and ask if you can perhaps tell us a little bit more about the conformant test suite for I3C. Kind of explain what the scope is, what it covers, and how it helps implementers implement the specification.
Thank you, Ian. Yes, you are right. As you have already mentioned, the I3C work group has already taken advantage of the MIPI face-to-face events to organize also a plug-based event to test the interoperability and also among different implementations of I3C between different vendors. This had given the opportunity for vendors to test their devices and their compatibility with other vendors, while if there are some misalignment on implementation, also the I3C work group can take that as an input and then improve on the next iteration of or on the future development of I3C, and also provided MIPI also with a level and maturity of implementation. But in the past 2 years, as we all know, due to COVID, it was not possible to have any face-to-face meetings, which meant that there were no plug-fest events to check for interoperability. And this has also accelerated the development of the CTS, and CTS stands for the Conformance Test Suite. And it's the CTS is a technical developed to assist companies to do tests on devices by themselves or with each other, using the CTS as a guideline to ensure interoperability. And the CTS is also developed to cover a subset of I3C protocol that the I3C, I'm sorry.
That's okay. Looks like we've had some technical difficulties there. Perhaps I could turn to Tim. Again, perhaps you might be able to just give a little bit of a flavour about what's happening with the CTS, the latest status, and again, how we're kind of coping with the absence of face-to-face test fests.
Yeah, absolutely. It has definitely been a challenging couple of years without having any in-person activity. As anyone knows, in the past we've had these face-to-faces and had the interoperabilities, which not only allowed us to better advance the specification and learn about that, but it allowed other companies to test their implementations and make sure that they were on the right track and be able to come here and ask, come face to face and ask the developers, hey, I'm seeing this happen with our implementation. Can we get some advice? And I can tell you for sure, as things are moving back towards in person, we're excited to get back to there. We as the developers, we like talking to the people who are actually getting their hands on and putting our work together, and we want to make sure that we're doing it with the easiest the use for the developers. We want to make it as easy as possible on them, but for complicated technologies such as I3C, it gets difficult. And so that's why we've put so much work into our compliance test suite, because we feel like in a way it bridges that gap between specification and implementation. It helps people navigate that, deals with common issues, common areas where maybe implementation could be taken different ways, so that we want to test that specific area to make sure everybody, despite translation of the spec, that we're all landing and we're all implementing in the same way, so that when it comes to deployment, that everybody's working together, that we're seeing as few issues and problems, because we all know that that's just going to go and make this technology even greater and greater.
Thank you, Tim.
Sorry
right?
for.
It's okay. You're back.
Yes,
so I think
sorry for the problem.
No problem at all. No problem at all. We're nearly the end of the session now, so really we need to kind of get to a stage of wrapping up. Just on the subject of test suites, Yul, would you just like to say any last kind of few words there?
Yes, as Tim mentioned, it was a way of aligning and also testing the compatibility and interoperability of the implementations. But not only this, but the vendors that are test equipment manufacturers, controller manufacturers, and also the vendors that are manufacturing target devices are all part of the development of the CTS, which means that the I3C work group has put on the effort to extract some common features that are required to ensure that an I3C device is capable of working as a target device or as a controller device. And by using the CTS, we can ensure that until we get in person and we are able to see face-to-face to test our devices, at least we can use the CTS as a way of verifying our implementations and checking also for the interoperabilities. This also helps for test manufacturers by implementing CTS and also using CTS as a way of building more complex models using traceability matrices of CTS to ensure that devices are capable of performing on a standard I3C bus.
Thank you all. Appreciate you giving us that those final words and that summary. I think we have gone slightly over time for our session today, and it's probably time now to wrap up. Tim, any just last words from yourself as the chair of the I3C Working Group?
Really just a big thank you to you, Ian, to MIPI, to all our panelists. There's been a ton of work that we've put in to these specifications, and we're excited to see them implemented, and we're excited to get feedback and hear from all of you. We want to know, what do you want to see out of I3C? We're continuing to continue development, and we're excited to see what the future of I3C leads.
Great, absolutely, Tim. Thanks for those final words. So yeah, all I can say is back that up. Thank you, panelists, for our session today. I think we've covered an awful lot of territory. Obviously, if you want to find out more, get in touch with MIPI. Thanks to all of our attendees for listening to us today. And thank you for attending DevCon 2021. I hope you enjoyed the overall show. I think that's it from us. All I can say is thank you and goodbye.